All right, guys. So before we get started, are there questions on the homework? Questions on the homework assignments? So 3.6, this is the last section of Chapter 3 we're going to be going over before the Chapter 3 test. Now, the quadratic formula, we got to this formula yesterday. We went through the process of how we went from the standard form, ax squared plus bx plus c equals 0, to the quadratic equation using completing the square. Now, you will never have to do that again. You'll never have to, probably most likely never have to see it again. The reason that I went through and did that is so that we have a background from where we get this equation. We understand how it works and the fact that, yes, it does work every single time. We're able to prove that this works every single time. This is a good equation to use. And I like that better than just giving you the equation and say, plug these in, go, just do it. Because now we have some background to it. It has some meaning behind it than it just being an equation that works every single time. And it works very nicely. We just need the values of a, b, and c, and we need to make sure the equation is equal to 0. So we look at this first one here, x squared plus 3x equals 5. I'm going to rewrite it so I don't have text all around it. But the first thing we need to do is get this equation equal to 0. So we can subtract 5 from both sides. On the right-hand side, our 5 and negative 5 will simplify out. Now, x squared, 3x, and 5 are not like terms, so we're just going to rewrite it back out, giving us x squared plus 3x minus 5. They were just asking a question. So, I think we feel good at getting this equation equal to 0, yes? All right, focus up here. So, the quadratic equation, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So it'll be helpful to know what the values of a, b, and c are, because for this equation, we're taking the corresponding values of a, b, and c and plugging them into this equation. Now, as we look at this here, a is going to be the number in front of x squared because this corresponds to the general form of ax squared plus bx plus c is equal to 0. Now, our value of a for us here is going to be 1 because the number in front of x squared is 1. Our value b, the number in front of x, is 3. And c, the number without a variable, our constant term, would be negative 5. So we have positive 1, positive 3, and negative 5. Questions on how we found the values of a, b, c? Now, the value of a is not going to have x squared. It's not going to be 1x squared. It's just the number in front of x squared. B is just the number in front of x, so it's going to be 3. It won't ever be 3x. C is the number without x. Now, once we have these values, we're going to go in and plug them in. So the first part we have here is the negative b. So we all have our negative, and then we're going to replace b with 3, because that's its value. Then we're going to move inside the radical, and our first term is b squared. So for us here, we're going to have 3 squared minus 4 times a. Now the value for a for us is 1 times c. Well, the value of c is negative 5 over 2a. Yeah, it does kind of look like an e. For AC. So that tells us we have negative parentheses 3 close parentheses plus or minus the square root of 3 squared minus 4 times 1 times negative 5 all over 2 times 1. So really all we've done so far is what? Plugged in the values of a, b, and c, yes? We're ready for the next step. Simplifying. Because as we look at this here, the first part that we have is this negative 3. I just got a highlighter. Because we have negative and then 3 in parentheses. Well, that's just what? Negative 3. That's all that is. It's just negative 3. We'll worry about what's inside the radical here in a minute, because the bottom of the fraction is 2 times 1. That's what we have on bottom, 2 times 1, and that is 2. Questions on what we've done so far? Now we're going to tackle the square root. Now when I do this, and I think the best practice with this, especially if we have a calculator. If we don't have a calculator, we're going to do it part by part. We would do the 3 squared first and get 9. Minus, then we do 4 times 1 times negative 5, or 4 times 1, which would be 4. 4 times negative 5 would be negative 20. So we have 9 minus negative 20, and work through that there. Now we have a calculator, and we can use the calculator. And I'm going to use the 30XS. 30XS, I like it better than the graphing calculator. Graphing calculator, as we've seen so far, can do a lot of nice things and really helpful things. But trying to type stuff in, I don't know about y'all, it's much easier and faster to type it on the yellow one, or 30XS, than it is to type some things into the graphing calculator. So what we can do is just type in 3 squared minus 4 times 1 times negative 5. I'm going to type everything inside the radical first. And the reason I say I'm not going to type the square root in first, I'm just typing everything inside of it, is because the 30XS, the yellow calculator, will not take the square root of a negative number. They just won't do it. We've seen it a few times up to this point, yes? So if this here, 3 squared minus 4 times 1 times negative 5 is negative, and I put it in that radical, it's going to pop up and tell me domain error, which is fine. I'll have to hit clear that out, and go back, delete the square root, and then have it tell me what it is, and then go from there. But at that point, we'd almost been better off to just found out what this is here. It tells us it is positive 29. So it tells us that what's inside the radical is indeed positive 29. So we have the square root of 29. Which means at this point we can tell the 30XS, hey, can the square root of 29 reduce? Is it possible to reduce it into a simpler radical form? And it tells us that the square root of 29 is square root of 29. It does not reduce. So this one here, we could have typed the whole thing in. We could have said square root 3 squared minus 4 times 1 times negative 5, and it told us it's the square root of 29. Now, if it had been the square root of negative 29, it would have thrown out an error. Wouldn't even simplify, just straight domain error. Then we have to go backwards. A little bit easier to find the square root, what's inside first, then we just square root it. Questions on this so far? Last thing we need to do is make sure that this number, the number in front of the radical, and the denominator don't all share a common factor. If they have a greatest common factor among those 3 spots, we have to reduce it. This one here, is there a number in front of our square root besides 1? No. So there is no greatest common factor between the 3 terms. So it's telling us that the solution for this here is negative 3 plus or minus the square root of 29 all over 2. That's it. Questions on this here? So I would say really the most challenging part of this quadratic formula is just being able to simplify down, to reduce. Are you ready for the next one? I'm going to rewrite it. I don't think y'all need to, because y'all should have enough space right there on your page. And I don't think you also have all to solve this equation using the quadratic formula written all around it. But what's the first thing we can do? We can subtract 10 from both sides. Ten minus 10 on the right-hand side is going to give us 0. Times 3x squared plus 4x minus 10. A, B, C. What's the value of A? 3. What's the value of B? 4. C is negative 10. Because if we had minus 4x, B would be negative 4. If we had negative 3x squared, A would be negative 3. So first thing we have is negative B. So we'd have the negative. And then in parentheses, I'd put the value of B, which is 4. Plus or minus square root of. So B squared would be 4 squared. Minus 4. A is 3. C is negative 10. All over 2A, so 2 times 3. So we plug A's value of 3 in its 2 spots. We plug B's value in its 2 spots, and then we plug C into the only place C shows up. Questions on this here? Well, the first thing I would simplify is our negative 4, which is just negative 4, because we have negative and then our parentheses 4 is just going to simplify to negative 4. The denominator, 2 times 3 is 6. Those are always the 2 places I go to first because, 1, we're just changing the sign from positive to negative or negative to positive, because if we have negative negative 4, that's going to become positive 4. Negative 4 is just going to be negative 4. On bottom, 2 times 3 is 6. 2 times the number is going to be nice. Now, the only thing we have left is the 4 squared minus 4 times 3 times negative 10. I just plug it in. I'd grab the 30xs and tell it 4 squared minus 4 times 3 times negative 10. It tells me it's 136. Then if we want to, we can immediately tell it, take the square root of 136 for me. 2 square roots of 34. It's not negative, so we don't have to worry about pulling that negative out as I. Since it's in the square root, it's just 2 square roots of 34. Questions on how we got to this point here? And we feel kind of comfortable with this so far, yes? So before we're done, just for formality's sake, we need to look in the 3 spots. The 2 on top, the number in front of the plus or minus, the number in front of the radical, and the number on bottom, which in our case is negative 4. Really, we're looking at 4, 2, and 6. Do 4, 2, and 6 have a number in common? 2, yes? We have to simplify it. We have to reduce out that factor of 2. Now, I'm about to walk through the mathematical way, quote unquote, one of the mathematical ways to do it. I'm doing this so that we see how this works and how we would reduce it. This is not how we're probably going to be doing it, especially once you start working these. Because the way that we can do this, or especially show that this works, is if we look at the numerator, we do know that there is a greatest common factor between negative 4 and 2 square roots of 34. And what we can do is we can factor it out. If I divide the top 2 numbers by 2, negative 4 divided by 2 would give us 2, so we have negative 2 left inside. 2 square roots of 34 divided by 2 is just going to be the square root of 34, so it's left inside. We still have the plus or minus. On bottom, we have 6. Because it hasn't changed. We just pulled the number out on top. Now, with fractions, multiplication works a lot nicer than addition and subtraction. Because we can multiply 2 things. We multiply numerator with numerator, denominator with the denominator. And since the negative 2 plus or minus the square root of 34 is on top, we can kind of push it off to the side. We've done this with variables time and time again. When we say 2x over 3, we can really say 2/3 times x. We can push that term on top to the side. Now, the reason I do that is because we can see what's being multiplied in front of it now is 2/6. Well, 2/6 reduces, yes? And it reduces to 1/3. Which is really just telling us that we have x is equal to negative 2 plus or minus the square root of 34 over 3. So we kind of see this is the process if we wanted to do it step by step, go through the correct, quote unquote, correct way to do it to simplify that greatest common factor out, reduce it out of the top and bottom, and then rewrite it in this form. But really, what did we do? We just divided each of those 3 spots by 2, yes? So really what I could have done at this point here is said that we are dividing each of these terms by 2. Now, negative 4 divided by 2, we can see that kind of nicely. Negative 4 divided by 2 is negative 2. 6 divided by 2 is 3, yes? Now, we have to be careful with the 2 square roots of 34 when we divide by 2. Because if you typed it into the 30xs, parentheses 2 square root of 34, close parentheses divided by 2, it'll tell you it nicely. Because we're dividing the 2 in front of the square root by 2, not what's inside the radical. Because it's very tempting to go, okay, 2 divided by the square root of, or 2 square roots of 34 divided by 2. 2 divided by 2 is 1. Square root of 34 divided by 2 would be the square root of 17. No, we can't do that. We're just dividing the number outside of it by 2, which does reduce to 1, telling us it's negative 2 plus or minus the square root of 34 over 3. We're doing the exact same thing. We're just not doing it in 1, 2, 3, 4 steps. We're doing it in 1. Okay? Can we kind of see how that works? Now, even if the negative 4 and 6 had a common factor of 2, but instead of 2 square roots of 34, we just had the square root of 34. There's not 1 in common in all 3 spots. We're leaving it. We're leaving it there. Because if it looked like this here, no. That is the final answer. We're not going to split that to 2 separate fractions and have negative 4, 6 plus or minus the square root of 34 over 6. We're not splitting it to 2 fractions. Simplifying 1. If it's common in all 3, we will simplify. If it's not common in all 3, leave it. Leave it as is. Questions on this here? We're going to look at one more. We're going to look at this one here, then we'll finish this up on Monday, or at this point, the joke with most things, next month. But ABC, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So at this point here, I need the values of a, b, c. A would be 1, because it's the number in front of x squared. If the number is not written, it's understood to be 1. B would be, it's 6, but it would be negative, because since we have minus 6x, the value b is negative 6. And the value of c is 4. Positive or negative? Positive because it has a plus. It's not always has to be negative. It's just worked out that the last 2 before this had been minus 10 minus our number. So it'd be negative. Now we're going to go through and plug these in. And my biggest thing, especially if you struggle or don't feel comfortable with negatives, squaring up any of this process, especially with simplifying, the biggest thing I would say is, especially on the test, is write it out with the numbers plugged in. Because if we start here, well, we know that b is what? -6. So we start off with -6. Plus or minus -6 squared. -4 times a is 1, c is 4, over 2a, 2 times 1. And especially on the test, that tells me, at least at this point, the reason you did not get the correct answer was not so much you didn't know how to do it, because at this point we've set it up right. We know what we're doing here. It's most likely a calculation error, and I can start narrowing it down. If you plug it all in from the start, it's, for me, it's anybody's guess at what happened between there and the final answer. Because at this point here, we have -6. So negative and negative make a positive. On bottom, 2 times 1 is 2. So we have 6, plus and minus, and then 2. Inside the radical, we have -6 squared minus 4 times 1 times 4. Yep. Four times 1 times 4. I can tell you right now, the way I typed this in is wrong. It's not going to give us the correct answer. Because what is it missing? The parentheses are around the -6. Because the way the calculator is going to look at this, it's going to say -6 times 6. -1 times 6 times 6. It's going to square the 6 and then throw the negative with it. And it's going to tell us that this is -52, which is not right. Because it should be 20. Because if we look at this here, 4 times 1 times 4, that's 16. -6 squared, -6 times -6 should be positive 6 times 6, which is 36. So we're really looking at 36 minus 16. 36 minus 16 should be 20. The reason that the other calculation gave us -52 is the calculator did 6 times 6 and said it's 36. Stuck the negative on. So now it's actually calculating -36 minus 16, which would give us our -52. We kind of see the issue there. So especially with this here, and especially with these negatives, I just go and put the parentheses around it. Because if it had been 6 squared and we put them, +6 squared is 36, with or without the parentheses. -6 squared needs them. All right. Now we need to see if 20 will reduce. Square root of 20 will reduce. It does. Now we can say we're done as long as 6 are 2 squared roots of 5 and 2 do not have a common factor between the three of them. Well, unfortunately, they do. They all have the greatest common factor of 2. So really, we're going to divide these 3 spots by 2. Now our 6 divided by 2 is 3. We still have the plus or minus. 2 squared roots of 5 divided by 2, really we're dividing the number in front of the radical by 2. And 2 divided by 2 is 1. 1 square root of 5, or we can just say the square root of 5, yes? Now the number on the bottom of the fraction, 2 divided by 2 is, do I need to write a division of 1? No. So the number on bottom simplified completely, leaving us with 3 plus or minus the square root of 5. And that's it. Questions on this here? Now, for most equations, we've said this up to this point, I've said it before, we can always check it, we can plug it back in, yes? As weird as that looks as a number, we can still plug it in. So we can say 3 plus the square root of 5 squared minus 6, parentheses, 3 plus the square, well, it'd be helpful if I actually get the square root of 5. And then it was plus 4, yes? So all I've done is taken one of the answer choices. We can't take the plus or minus, it needs one or the other. We're either going to use the plus of 3 plus the square root of 5, or the other 3 minus the square root of 5. We plug it in. And what did our starting equation said this should equal? 0. So if this is the correct answer, I should be able to hit enter, and it tell me that it is. It's telling me it is the correct answer. Now the nice thing with the 30xs, I can go up, highlight it, and hit enter. It'll bring it back down. And what I can do, instead of retyping the entire thing back in, I can go and change it from positive square root of 5 to negative square root of 5 in both places. Hit enter again, and it'll tell me it is. So it's still the correct answer. So we can still type it in. We can still check it, even with the one we just had a minute ago, negative 2 plus or minus the square root of 34 over 3. We can plug them in. We can check and see, does it give me 0? Does it equal what the other side is? If it does, it's a solution. If it doesn't, it's not. We got to get that there. Now, branching this back to the ACT, because I will tell you this, with most ACT questions, I'm not going to treat them the same as we do in class, because what's the one thing that the ACT has on its test that y'all don't have on mine? Multiple choice answers. It has multiple choice answers, yes. So if it told us to solve this, we know one of the A, B, C, D answer choices has to be correct, yes? We can plug them in. We can plug each one in and check and see, does it make both sides equal the same thing? If it does, it's the correct answer. If it doesn't, it's wrong. And most likely, not most likely, only one of those is going to work. One of those is going to be the correct answer. So especially if it's just asking, solve this equation for x, we can plug the answers in, use the calculator, let it do it for us. We don't have to do this here. It's going to tell me what one of the correct answers is. We will finish the rest of this on Monday.